Good morning, everyone. Today, I'm actually going to be discussing on the last tension, between explaining and predicting in research world. Before now, we started, the lecture series where we're trying to distinguish between what we call a model explanation and model prediction, which we actually call to predict or to explain. And of course, before now, I identify five tensions. And of course, out of the five tensions, I've basically explained the first four tensions, and the focus today will be the fifth one. But before I go into today's tension, I think I'm actually gonna have a kind of recap on the other four tensions that I've discussed in my previous video. Now, I remember I actually started with the tension number one that I called, causation versus association. You can watch my previous video on that, on how that enables us to distinguish, between explaining or predicting. Okay, from there, I remember we moved to tension number two that I call theory versus data. Okay, you can also watch my previous video on that. And number three, we moved to another tension that we call the average observation versus individual observation. Okay, so for more information, you can also watch my previous video on that. And of course, before today, the tension number four that we actually discuss about is retrospective and prospective. Okay, you also need to refer to my previous video on that. So today, I'm actually going to be going through tension number five that we call bias versus variance. Now, I want to, make this point. In my earlier, or let me just say in the previous video, when I started, I actually mentioned the fact that there's a difference between explaining or predicting. You may be working on a project, you may be actually doing research, and you basically want to, you want to take a decision regarding that. Of course, you need to make your intention known. Okay, do you want to explain or do you want to predict? Okay, and I'm going to say, in general, when your intention is basically to explain, then it means you're actually pursuing what I call a causal goal. Okay, and that is most of the things that we do in statistics or in economics, in psychology, in sociology, in fact, in scientific community in general. Now, but when we are talking about if our intention is, is to predict, of course, what we normally, we use predictive model. It means we actually are pursuing a predictive goal. And of course, the machine learning community, of course, that is their area. Okay, and of course, I said something the other time that what would be gainful in scientific world is how we can actually translate, a causal goal, or, an explanatory goal to predictive goal. And I also want to remind you that initially, scientists, of course, they don't really like the idea of prediction. They believe that the prediction is to the is for the industries. Why their main goal is just to understand the world and explain the world. Yeah, and and they don't really work here about prediction. In fact, my economist friend argued initially that there's no difference between explaining or predicting, that the fact that he understand a certain phenomenon, you should be able to predict that. But I said no. Somebody in 1948 or 49 also have the same thought when he actually equated, the model explanation to model prediction. But it was some years after that they realized that, the uncertainty around the model explanation is different from that of model prediction. And I also going to say, this is more or less synonymous with you know with the difference between the basic and applied science. When you look at the basic science, the basic science is when we're trying to understand and describe the world, while in applied science, we actually use the relationship among variables under investigation to make prediction. But I want to tell you this, we actually need the two, in the sense that we need to be able to, for us to understand the world, for us to be able to be secured in this world. Of course, we need to, for us, understand, some basic fundamentals. We need to, so that we'll be able to describe that. And not only that, we also need to secure the future. So, and that's actually justify the reason why prediction is actually necessary. Okay, so on that note, I'm actually going to go into the tension number 5 that I call bias versus variance. I'm going to tell you this. The bias actually is, to me, is the worst enemy of every statistician, every economist, every psychologist, every sociologist, because, well, their intention is to see how they can minimize, okay, bias, okay, and believing that, okay, of course, minimizing bias, we actually go a long way in assuring on what I call an adequate representation, of the underlying theory, okay, on the data, okay. But I'm actually gonna bust your bubble now. When you make an attempt to, further minimize bias, of course, you basically gonna cause a different problem that I'm actually gonna call high variance. Okay, let me just for first, tell you the different. What do we mean by bias? Statistician, if they actually want to begin their operation of analyzing data, they actually started by way of specifying model, which I mean, the functional form, using the principle of subjectivism. And of course, they acknowledge the fact that the model cannot capture exact reality, and because of that, in their model, they basically gonna have the combination of signal and the error part. The signal is more or less like the deterministic part of the model, and the error term is the random part. And of course, error, the assumptions, they're going to be assumptions that will actually revolve, around the error. And therefore, I'm actually going to say, bias actually refer to simplify, assumption made, that enable, our target function easier to approximate. Okay, so that's what we mean, by bias. And of course, We can also refer to that, as a difference between the average prediction, of our model, and the correct value the model is trying to predict. And of course, I'm also going to tell you, bias occur when an algorithm actually has something that I'm going to call a limited flexibility to learn the true signal from a data set. Okay, so I told you the other time, statistician, and the economists and researchers in the scientific community that are actually pursuing cause a goal. Of course, the worst enemy is bias, and that is why they try as much as possible to minimize that. But I said in the effort will lead to another problem that actually call the high variance. Now, what do we mean by the variance? The variance here we're talking about the degree of change, that may be expected, in the estimation of the target function, as a result of using multiple set of training data. This is the situation you actually you collected different training data set on the same problem, and you use algorithm, the same algorithm, and on each data set you actually have you have different you one model for each. You get what I mean? And in the end, the variance is just more or less going to be the sensitivity of that particular model, okay, or the algorithm, okay, to that. Okay, so this is the situation. In I'm gonna say the what makes explanation different from prediction is just like those who pursue explanatory goal, I mean, the cause I goal, the statistician, the economists, and the like. I told you the other time, they focus more on the bias, reducing bias. Okay, but if they basically want to translate model or explanation to model prediction, or what they basically need to do. Of course, what the machine learning experts actually, what they do is to intentionally introduce, bias, even though the machine learning experts focus more on the reducing variance at the expense of bias. Okay, this is the point. The statistician, the economists, and the like, those in the scientific community focus more on reducing bias at the expense of high variance. Okay, and because of that, of course, their model are actually, very, interpretable, but they're basically going to have issue with prediction. But when you talk about the machine learning experts, on the other hand, what they do is they focus on reducing the variance at the expense of the bias, and that is the reason, even though their model will be consistent in terms of prediction, but the model will actually suffer the problem of interpretation. Okay, so I wanted to take note, of that. Okay, so like what I was trying to talk about is that how can we actually translate, what I call an explanatory goal to the predictive goal? At times, the machine learning experts intentionally, introduce bias, okay, because they will realize that there's no way we can actually single out one for reduction. We should have a way to to minimize the two together. So, but there's something I'm actually going to tell us now. If you have what we are actually targeting is low variance, low bias, which may be at times difficult to get. You get what I mean? But uh, let me just tell you some problems that we may have. Like, okay, if I have high bias, low variance, it's an issue. if I have high variance, low bias, it's also an issue. So which I wanted to, but I'm done. Let me first tell you, the implication, of having high bias, low variance. The high bias, low variance algorithm actually train model that are consistent, but they are inaccurate on average. So why are they inaccurate on average? Don't forget in my previous video, I made mention of the fact that statistician, the economists, they actually centered, you know, their analysis around average. That's why you're going to hear average effect, average treatment effect, average this, average that. Okay, so now situation where there's high bias, of course, the statistician don't want that, right? Okay, situation where there's high bias and low variance, it actually means the algorithm may be consistent, but it's basically going to be inaccurate on average. And the moment it is inaccurate on average, that may actually affect the interpretability of your model. Okay, now another serious issue is there's a high variance and low bias. Of course, statistician, what they actually target is reducing the bias, and of course, when they reduce the bias, that will be at the expense of the variance, because the moment you reduce the bias, the variance will actually go up. Okay, and in that situation, the algorithm actually train model that are accurate on average but inconsistent. You can say the two. So therefore, we actually need to have what I call a trade-off. Okay, and having a trade-off, we actually realize that the low variance algorithm, they tend to be less complex. Okay, why do they tend to be less complex? Because they have a simple structure, or they have a rigid structure that's not flexible at all. I'm actually going to give you an example of that. We talk about your regression, you talk about your naive VEs, or you're talking about your linear algorithm in general. They are no, they are less flexible, because they have kind of rigid structure, and because of that, we actually call them the low variance algorithm. And of course, we also have what we call the low variance bias, talking about the low variance, sorry, I'm sorry, talking about the low bias. Initially I talked about the low the low variance algorithm. I said the low variance algorithm, they actually less they are less flexible, I mean less complex, and they are rigid. So anything that is rigid, of course, is going to be complex. And of course, the low bias algorithm tend to be more complex. And if I want to talk about having more complex, they basically, because they don't have a rigid structure, they have flexible structure. An example of that is decision tree, the KNN, and so on, like that. And let me tell you this, we actually want to put a check. We actually want to have a kind of balance, and that is the reason why we at times we introduce what we call a regularization to reduce a complexity in a model. Of course, if you come across what we do in the lasso regression and the ridge regression, we actually, because we want to be guided by the principle of parsimony, what we basically are going to do, we can introduce what we call a penalty. Okay, the penalty, we do the regularization. Okay, so I'm going to say the moment we actually try to minimize the bias and the bias and the variance, of course, we actually going to go a long way in producing the best model with accurate prediction. And let me also tell you this, when we are talking about the expected error prediction in machine learning, it has three components. It has the variance of y, that is the variance of the response, plus the square of the bias and the variance of the fitted function. Now, if you take a look at the three, you basically gonna see, when I say the variance of the response, even without even if everything is fine, like there's no any assumption, the model is working well, there's no any mis specification and stuff like that. We're still going to have a variance of the response. There's still going to be variation around the outcome variable. Okay, no matter what, even if everything is fine. Then, of course, bias, which I actually, said the other time to be a simplified assumption, made by model to in order for us to approximate the target function, easily. Of course, there's always going to be that. Then the last part is just going to be the variance of they actually call the variance of F cap. The F cap is more or less like a predicted of function, and that error arise because we're actually using sample information, to estimate the target function. So the bottom line today is more or less like, okay, how can we actually distinguish between the variance and the bias, and how it relates to the difference between explaining or predicting. So of course, what we need to do is, if we really want our model to basically predict, okay, we actually need to control. There must be a balance between the bias and the variance. Of course, if our focus is entirely on pursuing course or goal, of course we may not worry about the variance. We may continue to target reducing the bias, which is what statisticians, the economists, and the like do. But if our goal is prediction, of course, we basically need to consider both, reducing bias and the variance. Somebody may want to ask, like, oh, in statistics, does that mean we don't talk about the variance at all? At all? Let me tell you this. I know we talk about some variance, maybe the variance of your estimator. That is not what I mean this time around. When I'm talking about the variance, okay, is the sensitivity of your algorithm, to the training, different training data set. So, I'm aware that, okay, in statistical analysis, when you are pursuing a course or goal, for you to be able to actually test hypotheses about your regression parameter, of course, the there are some assumptions. The beta has to follow normal distribution, must have a mean, and it must have a variance. Okay, the variance there is not the same variance I'm talking about. I know the variance of beta, right? The variance of beta cap, you have that, right? The square root of that would be the standard error of beta, right? And that will enable you to conduct statistical inference on your regression parameter, whether you want to construct a confidence interval for that, or you want to test hypothesis about that. That is not the variance that I'm actually talking about. Okay, the variance that I'm actually talking about is basically the degree of change that may be expected in the estimation of the target function. The target function is what the statistician actually call the functional form. So as a result of using multiple set of training data, that's exactly what I mean. Okay, so this is where I'm actually gonna stop today on this tension number 5, which is actually the bias and the variance. Of course, in my next video, I'm actually going to do the summary of all these tensions and the way forward. Now, I want to appreciate those that will be watching this video. We advise that you love, and share. Okay, until the next time I'm actually going to come your way again, make sure you stay safe and have a very beautiful day. Bye for now, everyone.